Hi folks, and welcome back to Math with Captain Rod. The purpose of this video is just to go through an example of calculating a Taylor series. So what we're going to do here is we're going to take the function y equals e to the x, and we're going to calculate the Taylor series. That's where I have t as a function of x at x equals 0. So what we're calculating could be called a Maclaurin series. So if you've watched my previous videos on this, a Maclaurin series is just a special case of a Taylor series. So first of all, let's talk about, how Taylor series are calculated. And I usually kind of write these out longhand. All right, so your Taylor series is approximation to a function, and it's equal to, f of a plus f prime of a times x minus a plus f double prime at a times x minus a squared over 2 factorial. And technically this has a 1 factorial here and a 0 factorial here. Plus dot 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 dot. So calculating Taylor series, you typically need a whole bunch of derivatives. So we have the function f equals e to the x, and I'm going to go ahead and calculate some derivatives. So the derivative of e to the x is not super exciting. Derivative of e to the x is e to the x. Second derivative of e to the x is e to the x. Third derivative of e to the x is e to the x. And I usually calculate 3. If you want 1 or 2 more for the sakes of showing patterns, that's perfectly good enough, or perfectly fine. All right, so now I've got enough information here probably to write out my Taylor series expansion of e to the x. So t as a function of x is my little notation for Taylor series. All right, so the first term, f prime or f of a, and again we're doing this at x equals 0. So in this case, the a would be 0, and I look over here to f of 0 is 1. Plus, okay, now we got f prime of 0 times x minus a. So I look over here, f prime of 0 is 1 times x minus 0. I'll go ahead and put the minus 0 in. Plus, right, f double prime at a. And I look over here at f double prime, which is e to the x, evaluated at x equals 0. That's going to give me a 1 times x minus 0 squared over 2. The 2 is coming from 2 factorial, plus f triple prime is going to be another 1 times x minus 0 cubed over 6. The 6 is coming from 3 factorial, 3 times 2 times 1. And that's usually enough. I usually just put dot, 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 or etc. or something like that. So our Taylor series here, and I'll clean it up a little bit, it's going to be 1 plus x squared over 2 plus x to the third over 6 plus dot, 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 dot. And sometimes it's nice to see if we can condense this, like write it in some sort of summation formula. Frankly, I think that these things pretty much are done at this point, but sometimes we can kind of collapse this. So our Taylor series, we're going to try to write as a summation now. Should be written sum. All right, so first I want to talk about these x's here and talk about my sum. If I start my sum at, let's say, k equals 0, and I look at the powers, first power, 0 power, second power, I'm going to call that x to the k. And that should take care of all the powers here. And we'll just run this sum to some integer n. And the only thing left to take care of here is their fractions now. So you'll notice in my example here, when k is equal to 3 here, we have a 2. I'm going to think about this for a minute. So I think what we're going to want here is just k 2 minus 1, k minus 1 factorial, I think will take care of that. So just make sure this works. This was the third term here, so k equals 3. 3 minus 1 is 2. 2 factorial is 2. That's good. I'm going to check this term. K would be 1. 1 minus, or I'm sorry, k would be 2. 2 minus 1 is 1. 1 factorial, 1. And this term, k would be 0. I'm sorry, 1. 1, 2, 3. Whoops. I see. I want to start this at 1. So k equals 1, k equals 2, k equals 3. Then this would be 1 over 1 factorial. I'm sorry, 1 over 0 factorial, which is 1. So This is the Taylor series approximation for e to the x around x equals 0. I usually, again, just kind of stop here. Usually once you have the pattern, that's good enough, but sometimes you can look up your answers. Some books will want kind of a condensed little form. So I hope this video helps demonstrate how to calculate a Taylor series. Have a great day.